February 20th, 1943. In the dusty hills of Tunisia's Kasserine Pass, General von Arnim confidently watched the approaching American tanks. "They can't operate without flags or messengers," he reportedly said. It was the common conviction among Wehrmacht commanders. The Allies did not have enough tactical discipline to win an armored engagement. That conviction was about to be crushed, not because of a surprise offensive, but because of a technology that the Germans didn't even know existed. Radios. But not ordinary radios. High-powered FM radios, unparalleled clarity and operational range that Germany never imagined achieving. In silence, the Sherman tanks moved as a coordinated unit, guided by an invisible network of commands, warnings, and counterattacks. This video reveals one of the most decisive and underrated weapons of World War II, the communication superiority of American tanks. An advantage that turned each vehicle not only into a war machine, but into a link in a lethal tactical network. While Germany bet on brute force, the United States invested in connection, and it was this network, built in silence, that won the battlefield even before the first shot. But before we dive behind the scenes of this quiet revolution, there's one statistic that defines everything you're about to see. In 1944, each of the 49,324 Sherman tanks coming off the American production lines received, without exception, a high-powered, stable FM radio with a range 3 times that of the Germans. In the same year, Germany was able to equip only 1 in 5 of its medium tanks with complete radios. The rest advanced in the dark, waiting for orders that often never came. Still, German intelligence kept calling it good American discipline. If you value this kind of historical revelation, where numbers tell ignored truths, support our work by liking and subscribing to the channel. This allows us to continue digging up the invisible weapons that changed warfare. February 20th, 1943. North of the Kasserine Pass, in the hot, stony interior of Tunisia, the 10th Panzer Army was preparing for confrontation with American forces newly arrived on the African front. The German command showed no fear. They considered the Allies to be unprepared, uncoordinated, stuck in slow and inflexible doctrines. They were partly right. It was the first major ground battle between experienced German tanks and American armor. But what they saw that morning was not in the war manuals. When Wehrmacht artillery observers reported movement of Sherman tanks toward the northern flank, the data was clear. 5 tanks were moving over uneven terrain, separated by valleys and elevations, with no eye contact, no signals, and yet they converged in perfect synchrony. One flank covered the other. Each assumed a position that completed the group's vision. In theory, this type of maneuver required visual signals, or an external command center, or longer response time. But the Shermans were acting as if they shared the eyes. General von Broich reportedly refused to believe the report. "This is impossible without line of sight," he noted in his diary. But it was just the beginning. What the Germans saw was a tactical network in motion, and they didn't know it. In Wehrmacht doctrine, radio was the privilege of command tanks. The others followed orders visually: flags, lights, tower rotations. Commanders trained in centralized control did not expect that vehicles separated by natural obstacles could react as one. But the Americans were operating under another paradigm. Unbeknownst to the enemy, each Sherman tank was equipped with a frequency-modulated radio, with power and stability that turned each vehicle into an independent communication node. It was not necessary to wait for orders. It was possible to receive them, transmit them, and even more, coordinate tactically without exposing officials. A radio, a microphone, a headset. The result? A real-time war. The Germans, on the other hand, were stuck in a logic of the previous decade. The Few G5, its main tank radio, had only 10 watts of power, amplitude modulation, and operated at highly unstable frequencies. Every engine firing, every ignition, every friction of the hull produced uncontrollable noises. The range in an ideal and stationary field was 2 to 3 kilometers. In motion, it dropped to less than 800 meters, and yet few tanks had it. In a platoon of 5 panzers, usually only 1 or 2 could transmit. The others only received orders, and often not even that. To most German commanders, the Shermans appeared to have an invisible commander tank, operating from some hidden point, sending out silent signals. But this figure did not exist. Leadership was diffuse, distributed. Any of the Shermans could take the commanding position, and that's what broke the enemy's tactical understanding. During that morning, German reports recorded American maneuvers in which isolated tanks alerted others to enemy positions, altered course, and flanked with precision without any visible signal exchange. The German artillery could not predict the movement. The flanks unraveled and rearranged themselves as if guided by an invisible plane. The plan was a network, and the conductor was the radio. In one of the episodes most cited by the Americans themselves, Lieutenant John K. Waters of the 1st Armored Division reported that he received a request for radio coverage of a tank that was not in his field of vision, but that accurately described the movement of a German unit approaching from behind a ridge. Waters moved his unit, intercepted the attack, and protected the flank. When the two tanks met minutes later, the enemy commander was dead. Communication had saved the unit, and the enemy never knew how. That month, more than 300 Sherman tanks operated in Tunisia, all with SCR-508 installed, all with working radios, all capable of speaking, listening, coordinating. On the same front, it is estimated that less than 20% of German tanks had operational transmission radios. The rest were isolated, silent, vulnerable. The irony: while the Germans watched the Americans with moral high ground, the Americans watched them with electronic precision. A tactical observation is worth highlighting. In one of the 10th Panzer Division's reports, an intelligence note stated, "American armored units demonstrate unusual agility, probably the result of rigorous training." The sentence, written in a tone of contempt, is now seen as evidence of the German error of judgment. What they called training was actually technical infrastructure, an advantage that Germany could not replicate due to limited output, doctrine, and vision. At this point in history, it is worth pausing. In 1943, the United States produced 11,400 SCR-508 radios. Germany, in the same period, did not reach 2,000 few G5 radios. The discrepancy was such that some German battalions did not even have radios for their command tanks. If this number surprises you, comment below with the phrase absolute power or logistics wins, because these data leave no doubt about who dominated the invisible field of war. And yet, the Germans did not change their doctrine. They continued to bet on the vision, on the gesture, on the commander's tower. But the rules were changing. American tanks weren't just on the battlefield, they were connected to him. And the war, from that moment on, was not decided only by what was seen, but from what was heard. In the next part, we will reveal the birth of the SCR-508, the radio that transformed the Sherman from an average tank into a collective warfare machine. The creation that began in silence, inside a civilian radio factory in Chicago, and ended up dictating the course of World War II. The real turning point of the war didn't begin on a battlefield. It began in a quiet engineering room in Chicago in 1941. The Galvin Manufacturing Corporation, still far from adopting the Motorola name, had been hired by the United States Army to solve a technical problem with profound tactical implications, to develop a communication system for tanks that would be stable, resistant, clear, and reliable in extreme conditions. The challenge was monumental. Most military radios used amplitude modulation, or AM, the same technology that transmitted music at home, but failed at the slightest mechanical noise on the battlefield. Engine vibrations, ignitions, sparks, metal shielding, and even the movement of the tracks interfered with the signal. Galvin's proposal was bold: to abandon AM and bet on the little explored frequency modulation, FM. The idea was not new, but it was still considered complex, unstable, and expensive for mass use. The one who believed it was Daniel E. Noble, a young engineer who envisioned FM as a solution to static noise. Noble had the support of Henryk Magnuski, a specialist in radio frequency, who took on the central problem: adapting an FM system to work inside a 30-ton tank, under heat, dust shocks, and intense electromagnetic interference. In a concerted effort of applied innovation, they redesigned circuits, created mechanical isolations, developed noise suppression filters, and frequency stabilizers based on quartz crystals. The result was the SCR-508, a modular system with two BC-603 receivers, a BC-604 transmitter, 10 fixed channels, and 25-watt power. This meant not only superior reach, but absolute clarity. While German radios picked up each explosion as static, the SCR-508 isolated the sound of the voice and filtered out the noise of the engine, Field tests demonstrated that communication remained clean even during heavy gait, under fire, or on the move. More than a radio, the SCR-508 was a complete control system. The tank commander could listen to two frequencies simultaneously, for example, the platoon and the company, and switch between them in real time. Integration with the BC-606 intercom allowed all crew members to talk to each other, which increased situational awareness and response speed. In the American model of mechanized warfare, this was not only convenient, it was doctrine. Tactical operation in the field required flexibility, and flexibility required constant communication. The great innovation of the SCR-508, however, was in the invisible. It transformed each tank into a network node, and this network grew with each new vehicle equipped. When the Army standardized the SCR-508, SCR-528, and SCR-538 sets for medium tanks, it created not only interoperability between vehicles, but an intelligence mesh capable of operating without line of sight, without dependence on messengers, and without centralized commands. The logic of rigid hierarchy dissolved into a distributed intelligence. Each commander could act, warn, call for reinforcement, or transmit orders without waiting for the top of the chain. The network was alive. In industrial terms, the production of the SCR-508 was a separate achievement. In 1942, 3,800 units were manufactured. By 1943, that number had risen to 11,400, and in 1944 it exceeded 24,000. In total, more than 50,000 radios were produced during the war, a number that ensured the full equipping of all 49,324 Sherman tanks built. No other nation has achieved this. Germany, with chronic supply problems, factory dispersal and Allied bombing, produced fewer than 6,000 FUG-5 radios during the entire war. Many of them never reached the front. The SCR-508 weighed 181 pounds, contained more than 2,700 individual components, and operated between 20.0 and 27.9 MHz with 0.01% frequency stability, thanks to crystal control. It was a miracle of precision engineering done en masse. And herein lies the irony that would shape the fate of hundreds of battles. While the Germans bet on superior but isolated tanks, the Americans bet on average but connected tanks. The Wehrmacht doctrine treated communication as an accessory, the American doctrine as a weapons system. Technical reports from the time record that FUG-5 radios used variable capacitors that lost tune with any vibration. The SCR-508 maintained its frequency even when the tank was moving in combat or under fire. Every time an American tank moved, it spoke. Each time a German tank advanced, it was mute. At the end of 1942, the first American armored unit equipped with SCR-508 arrived in North Africa. The turnaround was still invisible. The Germans saw tanks, but they were being surrounded by a net, and this network was already beginning to change the battlefield without firing a single shot. In the next part, we will look at how the German centralized command doctrine, designed for tanks with limited radios, collapsed in the face of the American ability to decentralize, and how Germany's operational pride, its hierarchical structure, turned into a fatal weakness when exposed to the invisible flexibility of radio. In the 1930s, few military personnel understood the impact that radio would have on mechanized warfare. One of them was Heinz Guderian. A career officer, ruthless theoretician and architect of the Blitzkrieg, Guderian insisted, before any army in the world, that German tanks be equipped with radios. In his books and doctrinal instructions, he emphasized that the speed and impact of an armored unit depended not only on mobility or firepower, but on the ability to keep the command flowing. He knew that tanks that don't communicate fight like loose pieces. For this reason, the first Wehrmacht panzers in the 1930s were pioneers in this regard, and by the outbreak of war in 1939, Germany's command vehicles were already carrying onboard radios. The problem is that the time and scale of the war turned this innovation into an illusion. Over the next few years, as fighting multiplied and the front lines stretched for thousands of miles, German industry was unable to sustain the distribution of this technology. In 1940, only command tanks had full transceivers, so-called FUG-5, capable of transmitting and receiving. The other tanks, in most platoons, operated with FUG-2 radios, which only received signals. This created a one-way and fragile chain of command. The commander was speaking, the others listened. but no one could respond, report changes, report ambushes, or coordinate changes in real time. And when that commander was hit, usually identified by the dual antenna or by his position ahead, the entire platoon lost the ability to communicate. Tactical silence set in. The German doctrine, so advanced in its initial concepts, did not foresee that the radio would cease to be an accessory and become a nervous system. The Americans, on the other hand, built their entire armored doctrine on the basis of voice multiplication. Each tank was a decision point, a sensor, a potential command unit. In the American war, there was no weak link. The structure was redundant, dynamic, self-sufficient. The difference between the two models was more than technical. It was philosophical. Germany believed in absolute centralization. The unit obeyed the leader, and the leadership was one. The United States bet on tactical decentralization. Any crew could take the initiative. Any commander could replace another. And this philosophy was only possible because of radio. The voice was not lost with the destruction of a single vehicle. It was still alive in others. This doctrinal difference was clear in post-war analyses. The United States Army evaluated more than 1,000 captured German tanks. The finding was alarming. Even among the most modern vehicles, less than a third were equipped with functional radio transceivers. In battles such as Kursk, and then in Normandy, this limitation became visible. When attacked from several flanks or separated by obstacles, the German platoons lost cohesion, hesitated to advance, failed to react in time. They had power, but they didn't know where each other was. They had cannons, but they didn't know where to aim. They had doctrine, but they did not know what was going on around them. In contrast, Sherman tanks, even with less armor and armament, compensated for each weakness with tactical awareness. The voice flowed like electricity between the vehicles. A platoon could split, regroup, move in pincers, call for artillery or air coordination, all without moving out of position. And when one of them was destroyed, the others took over, because they all had radios. The irony reached its apex in German intelligence reports. On several occasions, Nazi officials mentioned with surprise that American tanks act as if they are all commando tanks, but they never attributed it to technology. The most common conclusion in the intercepted documents was that the Americans demonstrate discipline and superior coordination. The technical truth remained invisible to many German commanders until the end of the war. This strategic blind spot was costly. During the Italian campaign, several engagements saw the collapse of the German command after the destruction of lead tanks. In one such episode near Cassino, a group of panzers stood still for 14 minutes in the open after losing their commander, enough time for the Americans to reposition artillery and eliminate 3 of the remaining vehicles. No one could take charge. No one could react. In the German structure, the death of an antenna silenced the entire platoon. Meanwhile, the SCR 508 radios operated stably, even under intense fire. Its crystal-controlled frequency kept in tune even with heat, vibration, and movement. What's more, each radio set was powered by independent dynamos with an electrical filtration system that eliminated interference. German radios, fed directly from the tank systems, were static with each acceleration. Even the energy worked against them. Guderian's lessons, while visionary, have been swallowed up by industrial reality. Germany simply couldn't make enough radios. The few that did have needed to be installed in priority vehicles, and even then its transmission quality was inferior. The doctrine that was born a pioneer ended up outdated. In 1943, German armored communication was 5 years behind the American one, not for lack of ideas but for inability to execute, and the battlefield does not forgive this kind of delay. In a December 1944 memorandum, already pressured by the accumulated defeats, Guderian, now Inspector General of Armored Troops, admitted, "The superiority of American tanks lies not in their construction, but in their ability to operate in a group with efficiency and speed. Our vehicles are isolated." In the next part, we will see how this isolation would become fatal. We will explore in detail the German Fu-G5 radios, their technical limits, and how their practical deficiency erased any chance of coordinated response in the heat of combat. The problem was no longer doctrinal, it was electric. In theory, the Fu-G5 was the standard radio of the German armored force, a 10-watt AM transceiver, with an estimated range of 2 to 3 kilometers under ideal conditions. But the battlefield rarely offered ideal conditions. In practice, this range dropped to a few hundred meters when the tanks were in motion, which included constant vibration, electromagnetic interference from engines, and electrical noise generated by internal sparks. Worse, the system did not include any type of active filtering against this noise. Every spark plug, every touch of the throttle, every spark between metal contacts resulted in static. The voice disappeared in the electric storm produced by the tank itself. During the offensive in Kursk, reports indicated that many units were unable to maintain contact, even with the platoon's own tanks. And since the German model predicted that only the commander's vehicle had a full transceiver, any loss of contact resulted in immediate isolation. Hand signals, turret movements, and makeshift flags became the only means of communication between heavily armed vehicles operating in environments of minimal visibility. By this time, the enemy was already playing another game. The SCR-508, with its 25-watt frequency-modulated and preset channels with crystal clarity stability, maintained a continuous signal even under movement, artillery fire, and topographical obstacles. During field trials conducted by the U.S. Army in 1942, the SCR-508 demonstrated effective range of 7 miles on the move and up to 15 in a stationary position. But the most impressive number was another. While German radios used adjustable components that lost calibration over time and with heat, the SCR-508 was locked in quartz crystals that guaranteed a frequency deviation of a maximum of 0.01%. This meant that all the radios were already perfectly synchronized before they even entered combat. There was no time wasted with manual adjustment or trying to tune during operation. It was to plug in and operate. From a technical standpoint, the Fu-G5 wasn't just inferior, it was outdated. Operating in the 27 to 33 MHz band, it suffered direct interference from poorly insulated electrical systems, and its analog design offered no form of dynamic signal compensation. The result was noise, delay, and mission failure. The irony of this story is that the solution was in front of them. Guderian in the 1930s had already predicted that modern warfare would require real-time command. But the execution of this vision was stifled by an industrial system incapable of producing radios at scale, and by a doctrine that never allowed for the true decentralization of command. If you're enjoying unraveling these facts, where technology changes the course of war, show your support. Like and subscribe so we can continue to bring you in-depth content like this. Back on the battlefield, the consequence was predictable. German tanks fought in isolation. In clashes against American units, the accounts of captured crews revealed the shock. While awaiting orders, the Shermans were already repositioned. As they tried to understand what had happened on the flank, the Americans were already calling in artillery. In 1944, a German commander handwrote in his campaign diary, "The enemy tanks move as one. When one shoots, the other already protects. We act as if each tank is a separate army." The phrase reveals more than an outburst. It reveals the functional collapse of a voiceless mechanized army. In the next part, we'll explore how the Americans took this communication to the next level, turning the Shermans not just into connected vehicles, but into living parts of a mobile tactical network where every tank could think, react, and command. A decentralized system so efficient that Germany has never been able to understand, let alone imitate. In 1943, something began to change in the behavior of American tanks. It was not a change in armament, nor in armor. It was tactical. The United States' combat doctrine, based on the concept of combat command, was beginning to take shape with a speed that the Germans could not keep up with, and whose origin was almost invisible: the universal presence of SCR-508 radios on every Sherman tank. This technical detail allowed for a tactical revolution that could not be understood by fixed hierarchical doctrines. Rather than forming rigid columns or relying on vertical orders, American units reorganized themselves in the field based on the need of the moment. They created mobile task forces with elements from different battalions, connected not by an original plan, but by direct voice. A platoon of the 2nd Armored Division could in minutes integrate with a company of the 1st Mechanized Infantry Division, crossing commands, sharing intelligence, and launching a synchronized counterattack, all without the need for messengers, maps, or intermediaries. Each radio was a window. Each commander was a link of command. The result was a flexible, fluid, adaptive war. In the field, the Shermans operated like a living network, Tanks advanced, retreated, repositioned themselves in response to real-time threats. When one unit took heavy fire, another could cover immediately. When an ambush erupted, the surrounding vehicles were already on their way even before the first grenade hit the ground. This ability to regroup and counterattack seconds apart negated one of Germany's main advantages, the impact of surprise. The enemy, accustomed to disorganizing formations with quick attacks, encountered American units that restructured themselves like a swarm. What seemed like tactical disorder was actually distributed response, and behind it all, a 181-pound radio operating at crystal-clear frequency. The contrast with the Germans was brutal. The Wehrmacht doctrine called for centralized organization, with orders flowing from top to bottom. The commander was the mastermind of the operation. The subordinate tanks were arms that executed. Without constant communication, this structure collapsed at the slightest disturbance. When the commander fell, the arms stopped. The Americans, on the other hand, have developed a tactical architecture based on resilience. Any platoon commander could make decisions. Any outlet could take on the role of field reporter. The tanks, even separated by elevations or distances, maintained functional cohesion. Instead of silos, they were interconnected sensors. This tactical decentralization was only possible for one reason. Everyone spoke the same language, in the same system, on the same network. Interoperability between units was not a luxury, it was a guarantee. The U.S. Army standardized its radios not only for tanks but for trucks, infantry units, artillery, and aviation. This meant that a newly arrived division from another theater of operations could integrate into an ongoing offensive without interruption. The radio was already tuned, the codes already defined, the protocol trained. Germany could not imitate this. The multiplicity of models, the scarcity of radios, and the absence of standardization between armored forces, infantry, and artillery made the unification of command networks impossible. In one episode in Normandy, a battalion of the U.S. 3rd Armored Division was radioed to the presence of a Panzer Division to the rear of a flanking line. In less than 15 minutes, infantry and tank units from different regiments moved in and prepared an early ambush. The Germans, who believed they were attacking by surprise, encountered a coordinated fire corridor. When the German artillery officer was captured, he confessed that they did not even know they were being watched. The network was already operating, and the enemies once again fought alone. In the American model, there was no blind tank. Everyone knew where they were, who was under attack, who needed reinforcement. It was a collective intelligence operating on caterpillars. Radio was no longer communication. It became consciousness. Throughout 1944, the combat command structure became the heart of American mechanized doctrine. Units were organized ad hoc, with mixed elements of tanks, infantry, and artillery, assigned to specific tasks and constantly reorganized. Command did not depend on geography or hierarchy, but on mission and connection. In practical terms, this meant that where the Germans saw disorganization, there was elasticity, and where Americans saw rigidity, there was fragility. General Edward H. Brooks, himself commander of the 2nd Armored Division, wrote after the war, "Our greatest asset was neither speed nor firepower. It was the ability to form cohesive groups in minutes, with elements from different parts of the front, united by voice." That voice was the SCR 508. Technology allowed for the strategy, and strategy decided the battle. German doctrine, however refined, however experienced, could not compete with an architecture that operated as an organism. They fought with war machines. The Americans struggled with decision networks. And this concept, which would only be formalized decades later as network-centric warfare, was already a reality in 1944, on the hull of every Sherman in the field. In the next part, we will see how this network began to impose itself even in tactically lost battles. In Kasserine, where the Germans won on the map, they were defeated in the air. Because while tanks were destroyed, American voices kept transmitting, and the enemy, even if triumphing, did not understand why he could not silence them. In February 1943, German forces of the Afrika Korps achieved a tactical victory at the Kasserine Pass, forcing American units to retreat in apparent disorganization. For the German High Command, it was a confirmation of their operational superiority, the belief that the Americans were inexperienced, poorly coordinated, incapable of holding out against a veteran armored force. But behind the smoke and dust of the battlefield, something deeply troubled German intelligence reports. Even in retreat, American units seemed to know exactly where each other was. Scattered groups, separated by valleys and rock formations, still managed to operate as a cohesive force. Wehrmacht doctrine said that once visual contact was broken and the command tanks were destroyed, the formation should collapse. But with the Americans, this did not happen. They retreated, covering each other, relocating under fire, calling for artillery with precision, and maintaining communication not only between platoons, but between companies and battalions. Intelligence reports intercepted by the 10th Panzer Division describe something almost supernatural. American transmissions are constant, clear, and apparently originating from all tanks, not just command vehicles. This observation, made with technical perplexity, never generated changes in German doctrine. The explanation adopted was the same that permeated the strategic thinking of the Third Reich: discipline. The Americans, it was thought, had been well trained to respond to orders. The concept that they were operating with an invisible technological advantage through FM radios installed in all tanks was simply discarded. The Wehrmacht's own ideological structure prevented its analysts from conceiving of a decentralized system where any vehicle could coordinate and transmit. In German logic, only the commander speaks, the others obey. This belief made it impossible to identify the true nature of the American force. And this is where Kasserine quietly becomes the first American victory in a dimension that maps don't show, that of connectivity. As the Germans advanced on the ground, they believed they were breaking the line of defense. But in practice, they were just redrawing the geometry of the American network. Units that had been outflanked received artillery support coordinated by radio. Ambushed platoons alerted other formations. The tanks that still functioned took on relay duties, keeping the command alive even when the main vehicles were destroyed. In many cases, radios from immobilized tanks continued to operate, guiding reinforcements to their comrades. Instead of a total rupture, as the German doctrine predicted, what occurred was an organic adaptation, and this flexibility would become the hallmark of the American model in the following months. The greatest irony is that Germany, although victorious in that field, missed the chance to understand the type of opponent it would face from then on. General Hans-Jürgen von Arnim recorded that American formations demonstrated the ability to reorganize under pressure, but he attributed it to rehearsals in open ground, not to communication skills. No report from Afrika Korps identified SCR 508 as a deciding factor. Not even the Motorola name was mentioned. What the Germans called instinct was actually design. The architecture of FM radio was not improvised. It had been designed since 1941 for exactly this kind of fluid combat. The BC604 transmitter and BC603 receivers, operating between 20.0 and 27.9 MHz, allowed for multiple simultaneous channels with superior frequency stability. Even during bombings, the audio remained clear, thanks to frequency modulation that eliminated interference from sparks, engines, and metal rails. When German artillery tried to cut command lines, it cut only air. The Americans operated wirelessly. Communication became a weapon, and silence a sentence. The most impressive thing was what happened after the battle. As the Germans celebrated the American withdrawal, U.S. First Army units analyzed field transmissions. Each radio recording was studied. The losses were crossed with the intercepted communications. From Kasserine came improved doctrines. The Americans understood something the Germans did not see. They were losing tactically, but winning structurally. In the wake of the defeat, the realization was born that its tanks, although inferior in armor, were technologically ahead in an aspect that would decide the course of the war: cohesion in motion. It is at this point that the war changes. Kasserine did not teach the Germans to fear the radio, but it taught Americans to trust it as their most valuable strategic asset. From that moment on, each tank would be treated not only as a vehicle, but as a tactical terminal, and every commander would know that his voice could reach miles, even if his vision didn't reach 20 meters. In the next part, we will see how this silent victory translated into doctrine, how the interoperability of American radios allowed infantry, artillery, and armor to fight as a single unit, even when spread out over tens of miles. Because the real American war would no longer be fought with steel, but with waves. When the North African campaign ended, American tanks crossed the Mediterranean and landed in Italy. The new theater of operations presented a distinct enemy: geography. The open plains of the desert were replaced by narrow valleys, rocky slopes, and mountain passes. For any army whose command system relied on direct vision and messengers, this was the worst-case scenario. For the Germans, it was a tactical nightmare. Wehrmacht doctrine still insisted on visual hierarchy, flags, gestures, the commander in front. But on the rugged slopes of central Italy, one tank could be 100 meters from another and still completely invisible. The line of sight was blocked by hills, trees, and destroyed buildings. Under these conditions, war required a new language, one that did not need eyes. And the Americans were already speaking fluently. The Sherman tank's FM radio, with its range of up to 7 miles on the move and 15 miles in a static position, showed its true strength in this environment. Unlike German amplitude modulation radios, which were rendered virtually useless in terrain with multiple signal reflections, the SCR-508 operated stably. Frequency-modulated waves traversed canyons, bypassed obstacles, and kept the tactical unit alive even when the terrain said otherwise. At Monte Cassino, for example, platoons of tanks separated by abrupt elevations were able to conduct precisely coordinated attacks. It was a situation that, according to German textbooks, made communication impossible. But the Americans didn't just communicate, they maneuvered, flanked, and won. The Axis forces, relying on fixed networks and obsolete radios, lost track of the battle at every turn in the road. General Mark Clark, commander of the U.S. Fifth Army, stressed that the ability to maintain a continuous line of command between infantry, armor, and artillery, even in highly fragmented combat zones, was one of the decisive factors for the Allied advance on the Italian peninsula. By comparison, Germany was facing a communications collapse. With radio production prioritized for elite units, many tanks operated without transceivers. Orders were passed by messengers on foot or improvised signals, often under enemy fire. With each hill overcome, the tanks became islands. The disorientation was constant, and silence lethal. One statistic sums up this technological chasm. While the United States produced more than 50,000 SCR-508 radios during the war, enough to equip all 49,324 Sherman tanks with at least one radio, Germany manufactured only about 6,000 units of the few G5, its standard transceiver. This means that even at the height of the war, the rate of German tanks with two-way communication did not exceed 20%. The other 80% were fighting literally in the dark. If this comparison seems surprising, comment on logistics wins, because in fact, she won. The irony is that the Italian ground should favor the defense. Ditches, elevations, and forests are natural obstacles that reduce the effectiveness of armored vehicles. But the Sherman tanks, connected by radio, turned this environment into an advantage. They didn't need to see their allies to act with them. A platoon took a position. Another, behind the hill, already knew. One flank was attacked. The command coordinated reinforcements from units 3 kilometers away. The radio was no longer an accessory, it was the gun itself. Real-time coordination between units from different divisions has become commonplace. Makeshift battle groups, composed of tanks, infantry, and engineers, were formed in the heat of combat. The radio allowed this. Meanwhile, the Germans struggled with rigid schemes, requiring confirmations and formal lines of command that disintegrated as soon as the first antenna was destroyed. German doctrine said that tanks should maintain a closed formation, visually connected to the commander. In the field, this meant that when the lead tank was hit, the others fell silent. In contrast, any Sherman could take over the coordination, regardless of position. Frequency modulation, operating clearly amid the sonic chaos of combat, kept Americans on the network. Germany, on the other hand, saw its strength disperse in the echo of the mountains, not for lack of courage, but for lack of connection. At Anzio, Salerno, and Cassino, the Germans fought with ferocity, but their tanks were stuck in a logic of the previous decade, dependent on flimsy lines, visibility, and luck. The American radio dissolved the ground. Instead of obstacles, the hills became just parameters in an invisible tactical mesh. Signals traveled where soldiers could not. And with that, American doctrine flourished. In each quiet victory, the Allies learned more. Radio frequency was the new territory, and the United States mapped it with antennas, channels, and voice. But the war was still far from over, because soon this ability to communicate would reveal a new critical flaw, not on the battlefield, but within the American structure itself, a frequency error. a deadly blind spot, and it would be revealed in the hedges of Normandy. By dawn on June 6, 1944, more than 5,000 vessels were stationed off the coast of Normandy. The deafening noise of naval engines was only the backdrop to another, quieter, but as decisive operation as the 14-inch shots fired from the battleships. It was the continuous hum of radio transmissions, uniting tanks, infantry, artillery, and ships into a single tactical mesh. The invasion of France would not be won by armor or volume alone. It would be won by voice. At 06:30 a.m., the first Sherman DD, duplex drive tanks, equipped with SCR 508 radios, began to touch the beach. While the engines were still battling the waves, the crews were already transmitting position, obstacle, and German resistance information. In the tactical channel, each platoon reported its coordinates. In the support channel, naval bombardment requests were sent directly to the floating batteries. There was no time for delays. The enemy was in elevated bunkers, with firing ranges prepared for years. The difference at that moment was that the tanks were not alone. Each shot was answered, every advance covered. The radios allowed ships miles offshore to react in seconds to requests coming from the sand. An invisible wall, made not of concrete but of sound. However, not everything worked out as planned. In the midst of the chaos, a critical glitch appeared. Interoperability between tanks and infantry was not complete. The tanks operated at vehicle-specific frequencies, infantry and low-power portable VHF networks. In many cases, the soldiers were unable to communicate their position to the tankers. This led to dangerous incidents. At Omaha, a group of American engineers was nearly overwhelmed by tanks advancing on a sector still under enemy fire, simply because the two sides could not hear each other. It was a structural error, born of the separation between the radio systems of different branches of the military. The Army had prioritized the SCR 508 for armor, while the infantry operated with the SCR 536 or SCR 300. They were robust radios, but incompatible in frequency with those installed in vehicles. The solution did not come from the generals, it came from the sergeants. In a matter of hours, units began to improvise. Tanks began to pull off the beach with EE-8 phones welded on the sides of their turrets. Connected directly to the Sherman's internal radio, these phones allowed any soldier on foot to communicate with the armored crew. It was a field workaround, a tactical adaptation that was not in the manuals, but it saved hundreds of lives. Instead of waiting for a new doctrine, the Americans adapted. Communication between man and machine has been restored. The steel wall also became a listening node. The Germans, watching the scene from their positions at Pointe du Hoc, saw tanks advancing, infantry covering the flanks, and naval artillery responding with surgical precision. What they didn't see, and would never see, was the network that held it all together. They continued to believe that they were facing separate units, attacking under central command. They did not know that they were being surrounded by a system that learned in real time. Each tank destroyed ceased to be a hole in the formation and was replaced by another, already informed, already connected. During the second day of the invasion, a company of the American 2nd Armored Division lost 5 tanks in a German ambush. But in less than 30 minutes, reinforcements from another sector arrived on the scene, guided by radioed coordinates, not maps. When the Germans tried to repeat the attack, they encountered a curtain of fire. They were still reading the grounds. Americans were reading the system. For German intelligence, the Americans operated with luck. For American operators, it was just protocol. Later, captured reports from the German 352nd Infantry Division mentioned immediate coordinated response to each revealed position. None of the reports mentioned the word radio. For the Axis command, the war was still about movement and cannon. But in Normandy, every inch conquered was supported by a communication architecture, and each voice transmitted echoed like an order, not from a general, but from a collective. War was no longer conducted by eyes. It was led by ears. General Omar Bradley himself, reflecting after the landing, wrote, "The difference between success and disaster was measured in seconds of transmission. The wall of sound saved D-Day, but it still needed to evolve, because the next challenge would not come from the sea nor from the beaches, but from the trees. Rural France, with its fields enclosed by hedges, would force American tanks into a maze of ambushes, mines, and hidden positions. And once again, the voice would be the decisive weapon, or the fatal blind spot." On July 25, 1944, The morning began with a smokescreen and fire in St. Lo. Operation Cobra was underway. After weeks mired in the hedges of Normandy, the Americans finally glimpsed a breach. But victory would not come with aerial bombardments alone. It would come with coordination. And once again, radio would be the difference between advance and massacre. On that day, more than 200 Sherman tanks of the 2nd Armored Division received simultaneous orders, distributed over a communication mesh that united commanders, forward observers, artillery units, and infantry companies. It was the first time that the U.S. Army had tested, on a large scale, the concept of continuous armored movement coordinated by radio. Each platoon operated in real time, responding to threats that appeared a few meters ahead, and adjusting to the movement of lateral units that were not even visible. The dust from the dirt roads made it impossible to see beyond 50 yards. But the tanks knew. They knew where they were, they knew what was coming, they knew who would cover their rear, all by voice. The SCR 508 radios, installed on all Shermans, turned the breakthrough into a military choreography. When a unit was ambushed, it took 3 seconds to transmit the location. In less than 20, the artillery began to respond. The radio didn't just inform, he commanded the counterattack. No German doctrine provided for this. The Wehrmacht's tactical model was based on preemption: destroy the leaders, disrupt the chain of command, strike from silence. But in the face of Operation Cobra, there was no silence. Even when tanks were destroyed, the units did not retreat. Others took their place, guided by real-time coordinates. The sound of the explosions was drowned out by the steady voices in the headphones. It was like facing an enemy with eyes closed, but ears in every corner of the field. In operational terms, the difference was devastating. The Germans still relied on visual reconnaissance, delayed reports, and orders transmitted by couriers. The Americans, on the other hand, reconfigured the battle itself as it took place. If one flank weakened, another strengthened. If the resistance hardened, the attack redirected. The flexibility was total. General Maurice Rose, commander of the 3rd Armored Division, said after the operation, "We never had a fixed plan. We had the radio." This statement, made without pomp, sums up a historic transformation. For the first time, a mechanized force behaved as a single organism, capable of feeling and reacting like a living body. And, as an organism, it was resilient. The Germans tried to isolate the Shermans, but they multiplied. They destroyed a link in the network, but the signals continued. Each tank was not a weak point, but an active cell. This living network has created a new type of assault, the flow attack. Instead of advancing in columns, the tanks spread out like water, bypassing resistance, penetrating flanks, collapsing pockets before they were even identified. From the radio, the geometry of the battle changed. There was no longer a front line. There were interconnected zones of action, where each platoon was a tactical pivot. The German response was confusion. In reports from the 2nd Panzer Division, captured days later, the phrase appears, "They attack as if they know everything." And they knew. They knew where the enemy moved, where he fled, where he tried to outflank. They knew because radio made them ubiquitous. The power of the SCR 508, with its 25 watts and range of up to 15 miles, combined with the multi-channel organization, allowed for a layer of coordination unattainable by Germany. German FUG-5 radios, limited to 10 watts and prone to interference, simply couldn't keep up. In the open field, the Shermans turned into battering rams, but battering rams with closed eyes and attentive ears. When a German position emerged, the first tank did not fire immediately. First, it transmitted. He asked for confirmation, designated a target, waited for the artillery. Then the coup. The psychological impact of this sequel was devastating. The Germans did not know where the fire was coming from, nor why it was so accurate. They assumed again that the Americans were being guided by officers hiding in the hills. The reality was much simpler and much more advanced. The tanks themselves were the eyes, the ears, and the command. And the sound that connected them was more lethal than any shielding. But Operation Cobra was not just a victory of doctrine, it was an industry victory. Each tank in that breakthrough had been mass-produced, standardized, equipped with the same radio, trained with the same protocol. This meant that any crew member could operate any vehicle, that any part could be replaced without adaptation, that any channel could be accessed by any unit. This uniformity was the American logistical triumph and the collapse of German fragmentation. In numbers, Operation Cobra advanced almost 80 kilometers in 6 days. a speed unthinkable on French soil. But it was the radio that pushed. And for the Germans, it was still unclear what they were up against. As Captain Ernst von Lewinsky would confess after the war, "We thought we were fighting tanks. In fact, we were surrounded by antennas," and they had not yet said their last word. Because the real test of fire would come in the heart of occupied France, when the network of Shermans would have to face not only German resistance, but the saturation of the battlefield itself. The radio, now consecrated, would show if it could command even absolute chaos. On the plain of Bocage that stretched south of Saint-Lô, the Panzer Division came on the scene as the pride of German armored doctrine. Staffed by veterans of the Eastern Front and equipped with the latest Wehrmacht tanks and vehicles, it was not just a combat unit, it was a symbol, the elite, Hitler's final gamble to stem the American advance after the Normandy breakthrough. When Operation Cobra began, the Lehr was launched directly into the path of the US 7th Army Corps with clear orders: stabilize the front and crush the mechanized advance. But the reality on the field dismantled the myth. Instead of encountering slow, disorganized American columns, the Germans faced something their doctrine had never anticipated: talking tanks. The American attack did not come in predictable waves. He moved fluidly, with real-time adaptations. The Shermans, though inferior in armor and firepower to the Panther and Tiger, acted as a net. When Panzer Lehr tried to concentrate fire on one point, the Americans dispersed. When they surrounded a position, they were flanked by a unit that had been reported minutes earlier by radio, and by the time they finally destroyed one group of tanks, another group was already repositioned to fill the gap, coordinated, connected, synchronized. Lehr, even with its reputation, faced an enemy it could not fully see, because the battlefield was not just physical now, it was spectral. American orders traveled in the air, while those from Panzer Lehr ran into smoke. With overloaded command tanks and scarce radios, the division resorted to what it knew: flares, scouts, visual flanks. But in the chaotic environment of Normandy, with craters, debris, columns of dust and black smoke covering the sky, the eyes were no longer enough. Isolated crews without guidance became easy prey for artillery that always seemed to know where to aim. In just 3 days, Lehr lost more than 2,500 men and about 300 vehicles, a third of its total strength. The most devastating, however, was not the material losses. It was the inability to react. While the American units talked to each other, Lehr kept silent. When a battalion of the 902nd Panzer Grenadier Brigade was outflanked, it took nearly 2 hours to relay the situation to the divisional command, long enough to be destroyed. The division's commander, General Fritz Bayerlein, would later acknowledge, "Our tanks could not fight in a network. We threw fists. They fought with arms." This phrase, marked by resignation, summed up the culture shock. Germany was betting on concentrated power, on the visionary commander, on the superior vehicle. The United States had bet on the net. And networks don't have to be stronger. They need to be faster. The irony was consolidated with each failed attempt. The Germans saw Sherman tanks that moved as if they were controlled by a single brain. They believed they were facing maneuvers orchestrated by a central high command. But the truth was more disturbing. Each crew operated autonomously, guided only by the voice of other ordinary soldiers, transmitted by a radio installed in all tanks. There was no centralization. There was horizontal coordination. The German doctrine, hierarchical and linear, had no answer to this. When a commander fell, the chain collapsed. On the American side, any crew member could become the link of continuity. A commander hit was replaced by another on the same frequency, without loss of control. Panzer Lehr, with all its prestige, was now facing its own obsolescence. In the open field, his Panthers were formidable, but in Bocage, without reliable communication, they were blind giants. In a sector south of Le Désert, a group of 11 Panzer IV tanks was destroyed by an organized American ambush in less than 5 minutes, with only information transmitted via radio from a hidden observer. None of the German tanks fired. None of them even knew they were being flanked. They were hit from the side without reaction. American combat records indicate that the operation was planned and executed in its entirety in less than 7 minutes. From the first sighting to the last shot, the radio conducted every step. It was not force, it was synchrony. When American engineers designed the SCR-508, they didn't think about killing generals. They thought about avoiding silence. The radio was above all an antidote to paralysis, and in the battle against Panzer Lehr, the paralysis was German. The armored colossus fell apart gradually, unable to understand why its formations were always anticipated, why its reinforcements were intercepted, why its artillery was neutralized before it even fired. It was the invisible war, and the Wehrmacht elite had no weapons against it. After the operation, Bayerlein himself would write in a private letter, "We did not lose to tanks. We lost to what was between them." The phrase would never be published in official reports, but it echoed the truth that Germany refused to admit. The era of the lone tank was over. The future was one of connection, and the Americans were already there. What Panzer Lehr saw in Normandy was only the harbinger of a new era, because soon even the heavens would be connected, and when planes began to hear tanks in real time, the war would become a deadly symphony. The Luftwaffe would no longer be able to keep up, and the earth would shake at the sound of voices coordinated between ground and air. September 1944. In the open, misty fields of Arraucourt in northeastern France, tank warfare has reached its most symbolic point, the direct encounter between German armored theory and American connected practice. On one side, the U.S. 4th Armored Division, operating Shermans with inferior armor, modest firepower, and smaller gun range. On the other, the newly formed German Panzer Brigades, equipped with the dreaded Panther tanks, powerful, resistant, superior in all technical aspects. The logic for any observer was simple. The Germans would win, but the logic of the war had changed. Over the course of 2 weeks of fighting, the Shermans defeated the German armored force with an estimated 7-to-1 kill ratio. Weaker tanks with 75mm guns eliminated a disproportionate number of theoretically superior opponents. How was this possible? The answer was not in the armor, but in communication. Each American crew was a combat unit, an observation station, and a relay node. The SCR-508 radio turned each tank into a live antenna. When a Sherman spotted a Panther, he didn't have to face it directly. Transmitted, he coordinated, he called for reinforcements. It signaled flanking. He reoriented the group. It was as if all American tanks shared the same eyes. The Germans, on the other hand, were still stuck in the old doctrine. Only the command tanks had transmission capability. The others only received it. And if that tank was destroyed, which was often the case, the rest of the unit was blinded, deaf, and isolated. In Arraucourt, this failure became fatal. The hastily formed Panzer Brigade 113 attempted a surprise advance north of the village. The morning mist seemed to protect his movements. But for the Americans, protected by a communication mesh that worked on multiple frequencies, the fog was only a visual factor, not an operational one. Artillery observers, at Sherman stationed on distant hills, transmitted the exact coordinates. Within minutes, the flanking units repositioned. When the Panthers emerged from the fog, they fell into an ambush coordinated by radio, not vision. Reports show that, in less than 10 minutes, 10 Panthers were destroyed. Americans knew where they were before they even saw them, and when they saw it, they were ready. Now a fact that the Germans ignored, and that sealed their defeat at Arraucourt. In September 1944, each American Sherman tank operated with at least 2 active radio channels, one for internal unit communication and the other for external coordination. Meanwhile, only 40% of German tanks in the field had functional two-way radios. The rest depended on visual orders, gestures, or flag signals. If this data surprised you, comment below with "logistics wins," because in this case the war was decided more by frequency than by caliber. The fighting at Arraucourt made it clear that the doctrine of German technical superiority was obsolete. The Panther could destroy a Sherman with a single shot, but to shoot he needed to see, and to maneuver he needed to take orders. The Americans did not wait for orders. They conveyed initiative. Captain Bruce Clark, one of the commanders of the 4th Armored Division, described the battle as a game of chess played with voice. This voice came from the radio, and it was not a metaphor. During the offensive, Clark received constant updates from his companies, even under fire. The tanks broadcast their positions, confirmed safe zones, and requested air support, all in real time. A German attack that took 2 hours to organize was answered in minutes. At one point, a unit of Shermans was surrounded by Panthers on low ground. In a conventional doctrine, this would be a death sentence. But the American tanks did not resist. They retreated, transmitted, lured the Germans into a minefield that had been mapped the day before, and all this coordinated via radio. Result: 5 German tanks destroyed, 0 American casualties. Arrogance was more than a tactical victory. It was the ultimate validation of network warfare. For the first time in history, the ability to speak in real time has surpassed the ability to withstand impact, and the Germans knew it. After the battle, intercepted reports from the German High Command described the American tanks as too fast for our doctrine and impossible to isolate. It wasn't physical speed, it was speed of decision, because each radio replaced 3 officers, 5 messengers, and an entire chain of command. The war was changing, and the Americans were setting the pace. But what had not yet been revealed to the Germans was that this network of tanks, already lethal in its own right, was about to be connected to the sky, because the next phase of the conflict would include something even more unthinkable: tanks and planes talking to each other. A ground army with voice-coordinated air support, in real time, anywhere on the map. And this new capability would make obsolete not only German doctrine, but the very concept of the division between ground and air. March 1945. On the banks of the Rhine, in a Germany that was already bleeding on all sides, a breaking point was approaching, not just strategic, but symbolic. The Ludendorff Bridge at Remagen was one of the last intact crossings over the greatest natural obstacle between the Allies and the heart of the Reich. To the Germans, it was doomed to destruction. For Americans, it represented a unique chance. And what determined who would take it first was not the speed of the tanks, but the speed of the signals. On 7th of March, an advance patrol of the 9th Armored Division spotted the bridge still standing. The German engineers, under pressure, had installed explosives, but hesitated to detonate them, waiting for orders from above that would never arrive in time. The reason: telephone lines had been destroyed by Allied bombing. Emergency communication, which should have been immediate, was lost among rubble and delays. Meanwhile, the Americans were already broadcasting. In a matter of seconds, the news that the bridge was intact crossed the airwaves. The commander of the 27th Tank Battalion ordered the advance without hesitation. The Sherman's radios synchronized platoon movement, directed artillery support, and called for air cover. In less than 30 minutes, the American vanguard had crossed the bridge. In less than 24 hours, 1,000 men and dozens of vehicles were on the other side of the Rhine. The bridgehead was consolidated. It was the first crossing of the Rhine by Allied forces, and it was not decided by force, but by frequency. While the Germans were still discussing the explosion in delayed ciphered messages, the Americans had already taken the position and begun the construction of auxiliary bridges. The speed of the decision was not human, it was technical. Radio has weaponized time. The minutes the Germans wasted waiting for confirmation were the minutes the Americans used to win. General Günther Blumentritt, upon learning of the capture of the bridge, is reported to have said, "They crossed before we could even respond." This phrase was not just a military lament, it was the death certificate of a doctrine. The war was no longer about who saw first, but about who spoke first. And in this field, Germany was fighting as if it were 1918. With each offensive, the difference was accentuated. American radios didn't just transmit voice, they reconfigured the battlefield. During the taking of Remagen, the 9th Division redirected entire tank columns to support the bridge without losing a beat. Units that were more than 20 kilometers away were alerted, repositioned and relocated in a matter of hours. No messenger, no telephone cable, just voice, metal and movement. In contrast, the German divisions that were supposed to reinforce Remagen were held back by truncated orders, logistical ambushes, and lack of communication. One of the convoys was destroyed by P-47 fighter jets after being radioed by an advanced American tank. The Shermans didn't just cross the river, they commanded the skies by reporting in real time on enemy movements. Radio was no longer an advantage, he was a force multiplier. For every unit equipped with radio, the Americans struggled with the speed of 5. For the Germans, the equation was reversed. An isolated unit, even equipped, operated like an amputated cell. Time, once neutral, now had a side, and it was against the Reich. In operational terms, the Remagen Bridge accelerated the collapse of the Western Front. Within 7 days, the Americans had established multiple supply routes. The engineers had erected additional bridges in record time, while the Germans had not even been able to reorganize the defense. The capture of the bridge allowed the advance towards Cologne and the Ruhr to take place without interruption. The radio had become a stopwatch, and the Germans were always second or hours behind. When asked how the Americans managed to react so quickly, a German general staff officer replied bitterly, "Because they don't wait. They already know." But what he didn't know is that this time advantage was about to take an even bigger leap, because terrestrial radio, already consolidated as a command tool, was being integrated into an even more agile, even more decisive force: tactical aviation. Soon the tanks would speak to the heavens, and what started as a crossing would become a coordinated three-dimensional attack. The Remagen Bridge had been the harbinger. The next chapter would reveal the true fusion of soil and air. And this marriage of frequencies would leave no safe space for the Wehrmacht. April 1945. The Reich was collapsing, but what happened in the Ruhr was not just a defeat. It was the tactical obliteration of a force that no longer knew how to fight. With more than 300,000 German soldiers trapped between the Rhine and Lippe rivers, the so-called Ruhr Pocket became the largest encirclement of enemy forces ever executed by the United States Army. But what makes this episode more than a numerical feat is the way it was carried out. There was no grandiose battle, no epic counterattacks. There was a silent internal collapse, fueled by an invisible weapon: communication. The U.S. armored columns that closed the siege came from opposite directions, crossing destroyed cities, forests, and bridges, and yet they acted with a timing that seemed superhuman. Each platoon advanced, knowing exactly where the others were, not by maps, but by voice. High-frequency radios kept the divisions informed, articulate, and above all adaptable. There were no gaps. There was no confusion. It was a movable wall, in constant realignment. In contrast, the German troops inside the pocket lived in fragmentation. With their communication infrastructure devastated, they tried to operate with outdated orders, passed on by messengers who did not arrive or were captured. The units multiplied on disconnected islands. A battalion in Essen did not know where the division was in Wuppertal. A regiment in Hagen had no way of knowing whether the counterattack called for 2 days earlier was still on its way. Each position resisted in isolation. Each retreat was uncoordinated. Cohesion evaporated, and with it, morals. American intelligence reports intercepted scattered German communications asking for instructions from commandos that had already been annihilated. In some areas, soldiers surrendered without a fight when they realized they had been abandoned, not out of cowardice, but out of a total lack of direction. The decision-making network had disappeared. By contrast, the Americans operated as a single organism. One armored division might be 40 kilometers away from another, but it reacted as if it were only a hill away. The radium filled the space between the tanks. Each unit was a cell of a larger body. The war, which had begun with the Blitzkrieg, fast, concentrated visual, was now won by dispersed, invisible, and constant integration. A Wehrmacht officer captured in the Dortmund area stated, "We fought by sectors. They fought for the sake of a system." The phrase sums up the tragedy of German doctrine. Even with experienced men and heavy weaponry, the army in the Ruhr was paralyzed by misinformation. The upper command could no longer issue cohesive orders, and even when orders were given, they were too late. In contrast, the Americans improvised, adjusted, converged, all in real time. The radios in Sherman tanks now operated in a network with artillery, with infantry, with air units. Each enemy spotted by a tank could be eliminated by a fighter or a howitzer miles away seconds later. The German response time was hours, the American of minutes or less. It was no longer a question of having more men or more tanks. It was about knowing how and when to use them, and Americans did, because they listened, because they spoke, and because they connected everything. By the end of the operation, the U.S. Army had captured more than 317,000 German troops in one movement. It was the largest imprisonment of enemy forces in American history, and most remarkably, made with minimal losses. It was not a victory by brute force. It was a victory by the net. The Ruhr Pocket was closed, but what was closed there was a historical cycle. The war of great offensives and fixed doctrines died in that industrial valley. In its place, a new paradigm emerged, that of the war for integration, for adaptation, for time, not just for territory. And those who still struggled with paper maps and written orders were already defeated even before shooting. But what would come next would prove that this integration was still in its infancy, because soon the last frontier of connection would be overcome. Radio would cease to be just tactical and become strategic, connecting platoons to bombers, battalions to air divisions, and tanks to planes flying at 10,000 feet. A surface force about to be guided by the sky. In 1946, during post-war Allied interrogations, a pattern began to emerge in the accounts of captured German officers. Many of them, when describing American maneuvers on the Western Front, used terms such as impeccable discipline, admirable synchrony, or astonishing operational efficiency. But none of the hundreds of pages analyzed by the intelligence teams did the real factor appear: communication technology, the radio, the network, the invisible infrastructure that connected every American soldier as part of a living machine. For the Germans, what they were seeing on the field was the result of doctrine, not system. They knew what radio was, but they didn't know what a network was. His eyes saw tanks maneuvering together, columns converging with precision, artillery responding in seconds, but their minds translated it as rigidity, hierarchy, or even chance, not as integration. Even as prisoners reported the presence of radios on all enemy tanks, the General Staff reports insisted that this could not be the decisive differentiator. The German doctrine still operated in a visual and linear logic: see, order, act. What the Americans had built was something transversal: feeling, communicating, coordinating. Instead of acting in function of a center, they acted as a mesh, each unit with decision-making capacity, each voice with access to the whole. The irony of this story is that the solution was in front of them, in every battle lost, in every fluid and coordinated American advance. If you're enjoying unraveling these facts and diving into how the war was won in detail, show your support. Like and subscribe so we can continue to bring you this level of analysis. Let us return to the reports. In a 5th Panzer Division analysis of American actions in the St. Lo region, one reads, "The enemy infantry seems to always know where their armored cover is. The tanks, in turn, react as if they are being guided by a single mind." The phrase is impressive, but what comes after reveals the strategic abyss. Such synchrony is probably the result of repetition and disciplined training. No word on frequency. No mention of the SCR 508, the use of VHF-FM, or the existence of tactical interoperability. For the German High Command, the war was still conducted by men, not systems. This misperception was deeper than an equipment error. It was a paradigm error, a failure to understand that the war had migrated to a new dimension, where the first to adapt would win before it even began. In contrast, Americans were fully aware of the power they had built. Field manuals already treated the radio no longer as an accessory, but as a command vector. Officers were instructed to prioritize the integrity of communications over firepower. A tank without a cannon could observe. A tank without a radium was blind. The U.S. Army, by 1945, had become a distributed entity, capable of thinking, responding, and adapting in real time. And the most extraordinary thing is that his enemies continued to believe that they were facing brute force. They did not know that they were facing the prehistory of networked warfare. Most German generals would not understand the extent of the mistake until years later, reading the Allied reports published after the surrender. But the war was already over, and the trial had already been sealed not only by the destroyed tanks, but by the signs never heard. Silence, once again, had defeated arrogance. And if there was still any doubt about how much the Germans ignored this invisible revolution, it would disappear in the face of what was to come, because the next document would reveal something even more impactful. Germans had access to FM radio technology and rejected it, by doctrine, out of pride, by strategic blindness. The end of World War II marked the end of many paradigms, but also the quiet birth of a new era of command. Among the numerous legacies left by the fighting, few were as discreet and as decisive as the SCR 508. For laymen, it was just a military radio. But for post-war strategists, he was the embryo of a new kind of army, not just mechanized, but connected. The SCR 508 introduced more than frequency stability and superior range. He introduced the concept of distributed coordination. For the first time, technology allowed the command to be not a central entity, but a living network, where each unit had not only the mission, but the ability to react, relay, and influence. That seed grew. In 1955, when West Germany began to reorganize its armed forces under NATO supervision, One of the first systems adopted for Leopard tanks was an FM radio based on the principles of the SCR 508. The historical irony is blunt. What the Reich rejected, the Bundeswehr adopted. And more, he considered essential. Because the lesson had been learned, the world's most modern tanks, such as the US M1 Abrams and Germany's Leopard 2, are now mobile sensor, data, and communications platforms. The armor is sophisticated, the cannons lethal. But what defines its actual lethality is the ability to operate in a network, to share targets, receive real-time tactical updates, and coordinate with aviation, drones, and infantry. All of this goes back to the logic introduced in 1942 inside Sherman tanks that many considered outdated. The real innovation was not in the steel, but in the frequency. In the post-war period, the US Army developed the C3I concept, command, control, communications, and intelligence, as the basis of modern operations. All four pillars find in the SCR 508 their first operational anchor point. During the Korean War, the radios inherited from World War II still served with precision. And in the decades to come, the principles behind its architecture would be maintained, even with new materials, new bands, and new encodings. More than a radio, SCR 508 had been the first functional nerve in a military collective brain. Its impact has even reached the civilian sector. Motorola, which at the time of the war was still called Galvin Manufacturing, would use the learnings from the war to become the leading provider of mobile communications in the world. Frequency modulation, FM, proven on the battlefields of Europe, has become a global standard for terrestrial communications, and the notion that mobile systems can remain integrated even under extreme conditions has given rise to networks like the 911 emergency system in the United States, whose technological roots are tied to the architecture of military radios. Today, when a modern tank operator rotates his turret in sync with other units or calls in air support directly from his cockpit, he is operating within a chain of command that began with the SCR 508. And when modern armies define doctrines based on network-centric warfare, the so-called network-centric warfare, they are only giving a name to what, in practice, began with the American decision to equip all its tanks with radios capable of listening to each other. The enemy at that time did not see it. He didn't understand, he did not react, and he paid the price. What makes the SCR 508 a historic weapon is not its range, nor its quartz crystal, nor its electronic noise shielding. It's the fact that he showed the world a definitive truth. Communication is survival, integration is superiority, and silence on the modern battlefield is a sentence. But there was a detail that made this legacy even deeper. Because even before the SCR 508 became standard in total war, it had already been tested in the greatest laboratory of all, America itself. And it is there that we find the next link in this story, where the production of radios, in industrial volume, became possible not by miracle but by something even more powerful, the marriage between engineering and democracy. In essence, war has always been an enlarged mirror of the ideas that move a civilization. And no confrontation made this as evident as the clash between German and American tanks during World War II. More than shocks of steel and explosions of projectiles, it was the confrontation of philosophies. German doctrine believed in tactical genius, centralized precision, the quasi-religious hierarchy of order and obedience. Their tanks, masterpieces of engineering, were made to operate as autonomous fortresses, relying on the commander's vision and the rigidity of formations. American tanks, on the other hand, although inferior in armor and firepower, were designed as nodes of a network. No Sherman needed to be brilliant alone. It was enough to be connected, and this reflected a deeper principle, the value of the collective. While Germany prioritized top-down control, the United States invested in informed autonomy, in the ability of each soldier to make decisions based on shared data. The difference became fatal when the German commander fell and his unit was mute. On the other hand, if one platoon lost its leader, another took over, instantly informed. The SCR 508 wasn't just a radio. It was the materialization of a concept that intelligence is better distributed than concentrated, that flexibility is worth more than strength, and that an army that communicates thinks, and one that isolates itself repeats. War, for Americans, was not a display of brute force. It was an orchestra, each tank an instrument, each platoon a harmony. The battlefield wasn't a line, it was a living ecosystem, shaped by data, voices, alerts, decisions. The strength of the United States was in allowing this network to function, adapting in real time. That is why so many German officers, while respecting the technical capabilities of their armored vehicles, later confessed that they did not understand how the enemy could react so quickly, so cohesively, so precisely, even when everything seemed disorganized. It was the difference between a system made to execute orders and a system made to evolve, between the control tower and the network of trust. This lesson, today, goes beyond the military field. It is present in companies, governments, and societies. The 21st century is the direct heir to what the Shermans demonstrated in the hills of Normandy. That collaboration overcomes isolation, that speed of adaptation overcomes rigidity, and that winning is not about being the strongest, it's about being the most connected. The final irony is this: while Germany relied on the lone commander, the invulnerable tank, the visual superiority, the United States bet on something invisible, collaborative, almost ethereal. And it was this spirit, not force, that changed the course of history. But there was a detail that made everything even more symbolic, because the technology that made this revolution possible, it was invented by civilians, produced by civilian factories, tested on civilian roads, and made up of a country that understood that winning the war did not only require soldiers, it required engineers, workers, and antennas. And that's why, to understand the triumph of the SCR-508, one must now visit the place where it all began, the industrial heart of America. The next stop will not be a battlefield, it will be an assembly line. In every quiet corner of a battlefield, there's more than steel, gunpowder, or strategy. There are human choices. And when looking at the history of the SCR-508 radio, what emerges is not just a technical innovation, but a philosophical decision. A decision that begins before the fight, in the way a society sees the individual within the whole. Nazi Germany, with all its discipline and precision, formed armies like fortresses, robust, feared, isolated. Each commander, a center of authority. Each tank, an armored island. The United States, on the other hand, built its armies as networks. Networks of trust, communication, mutual support. Each radio a bridge, each soldier a vital knot. And at the heart of this system was a simple but revolutionary principle: no one fights alone. This was not just a military strategy. It was an extension of the values that underpinned that society. America bet on something invisible: listening, responding, connecting. And this bet saved lives. Because when one tank was hit, another already knew. When one platoon advanced, another covered. When a mistake happened, it was corrected in seconds. There was no room for lone heroes. There was room for operational solidarity. This story is not just about war. It's about the world we want to build. In times of tension, isolation, and noise, the greatest weapon remains listening, the ability to respond, to coordinate, to trust. If each person is a fortress, we will live on a permanent battlefield. But if each person is a link, we build a line of defense that no threat breaks. Therefore, the question that remains is not technical, it is personal. What would you rather be? An isolated tower with thick walls and narrow windows, or part of a network where your voice reaches, your presence adds, and your listening protects? The radio war showed something that history has been trying to teach us for centuries, that the real power is not in those who shout the loudest, but in those who listen best. It is not in those who close themselves, but in those who connect. And it is not in those who command out of fear, but in those who coordinate out of trust. The biggest shield is not steel, it is belonging. The irony is clear. While German tanks sought physical invulnerability, American tanks found functional invulnerability. They were more fragile on the outside, but invincible on the inside, because they were part of something bigger. And in the end, that's the only victory that really matters. But before closing this story, there is still one final mystery. Because while the American radios spoke loudly, clearly, and powerfully, the German generals had remained silent. And there's one last sentence, lost in a confidential report, that may explain why. At the end of the war, what was left of the German armies was not only defeat in the physical field, but the collapse of an entire model of thought. The doctrine that exalted the perfect machine and absolute command was destroyed not by thicker armor or longer guns, but by something that could not even be seen. The United States did not win with tanks alone. They won with radio waves, with antennas, with voices that pierced smoke, fire, and fear. They won because they understood before others that, in a modern war, the real combat takes place in information. The SCR 508 radio wasn't an accessory. It was the extended brain of a moving army. Each Sherman was more than a tank. He was a knot in a living, thinking, coordinated network. And it was this network that crushed the theory of German technical superiority. Because by the time a Panther was visually looking for targets, a Sherman had already called for support, redirected fire and set up an ambush, all while advancing. The lesson is brutal and universal. The strongest does not win. The most integrated wins. War has taught that volume trumps tactics, when volume is guided by collective intelligence, and that logistics, yes, this silent science, determines the strategy. No German officer summed it up better than General Heinz Guderian when he wrote, "We were not defeated by tanks. We were defeated by a system." If this story surprised you as much as it surprised those who lived it, support our work. Like this video, subscribe to the channel, and activate the bell. Here, each story is built with rigor, respect, and dedication to the truth. And now I ask you, what was the most shocking data you discovered in this video? Leave it in the comments. Your voice is part of our network. But don't go away yet. Listen to the next real story that will appear on the screen. Because if there's one thing this war has taught, it's that the next victory starts with the next piece of information. Always remember, logistics determines strategy. Watch the next video here on the channel with another incredible story.